Hello, my friend. I'm introducing the advanced model for simulating biochar binding with ions, the three-sided NICA-Donnan model. This time, I'm going to introduce the most basic knowledge about it. What is biochar? The model itself, how to obtain parameters, and simple utilization of it. This work is done by me and my co-authors in Berkeley University, Chinese Academy of Agricultural Sciences, and Shantou University. Thank you all. First, what is biochar? Biochar is made from organic matters like plant-based materials, manure, and sludge, pyrolyzed at a high temperature using furnace. The highlighted is the typical condition producing biochar. After pyrolysis, the biochar is produced. Biochar is widely used. For example, it can be used for the soil remediation because it can absorb trace metal ions, carbon sink in the soil, improving soil quality by adjusting the soil pH or improving the soil water resistance. In addition, it can also be used for reducing the nitrogen leaching emission. In this study, we focus on the absorption and remediation. As biochar has so many functions, can we put it into the soil right now? Nope. We need to be careful on the utilization of biochar because part of the biochar is very stable in the soil. Once it has been utilized in the soil, part of the biochar is a kind of permanent components in the soil. What can we do to assess the impact of biochar before utilization? With increasing usage of biochar, we need to know how much biochar we should use in soil. However, the traditional evaluation method is rely on the lab experiment. Sometimes the user of biochar can hardly access these instruments. Multi-surface modeling is another way to make this evaluation because we can predict the speciation of cations or anions without that much of the lab work. This is the concept figure modified from a graphic abstract of Bertian's paper. Uh, However, we do not have the yellow part is a soil. It contains different reactive surfaces like clay, oxides, and soil organic matter. We can model it one by one. However, we do not have the model for biochar. How to model biochar? Biochar is a complex material. We can see lots of functional sites on it. The oxygen center or nitrogen center functional groups like carboxylate group, phenolic group, or pyridine groups. In very short distance of these functional groups, the ion can form complexations with these functional groups. A bit further, we can see the blue and red colored area, which is affected by the electrostatic effect. This part has a volume which called the Donnan volume, and we call it Donnan phase ions can also be absorbed in this part. So first, we need to confirm the existence of acidic groups and basic groups. We did a meta-analysis on the PCC. The PCC of biochar has a, uh, has a bit similar but different between different washing methods. The spectrum study revealed the existence of these different types of functional groups. By the way, how to do this modeling? How to quantify the site density, how to quantify the site strength, how to quantify the site heterogeneity, how to quantify the electrostatic absorption? It's a question. As proton is the simplest ion, we use it as the probe to quantify the physicochemical properties of the surface of biochar. Let's see the left figure. The hydrogen ion complex with the carboxylic group. With its range of donor phase, the protein can also exist. Not only protein. The sodium ion can also exist here. Afterwards, there is another hydrogen ion in this system. It randomly moved to a close distance to the donor phase. However, it is fulfilled. Afterwards, it moved away again. The pH meter can measure this active hydrogen ion and reads as pH. This is mature technology. We call it acid-base titration. Now we have the charge density of biochar surface and equation of the equation of three-side NICA-Donnan model. With the help of equal set fit, we derived a set of parameters to describe the site density, proton affinity, heterogeneity of carboxylic group, phenolic group, and basic group of each individual biochar. The average value of each parameter was taken as the generic parameters, as highlighted line. What can we do by this set of generic parameters? The users can simulate the pH charge curve using this set of parameters without doing experiment. Moreover, very interesting, the net charge of biochar at different pH can be simulated. Not only one ionic strength, but also different ionic strengths. The contribution of different functional groups to the net charge of biochar can also be explained. The carboxylic group, site A, phenolic group, site A2, the basic group, site B. We can see very clear how these functional groups contribute to the net charge. All in all, this study lays the basis for the further model development to evaluate the biochar potential for in situ trace metal immobilization in the soil. Thank you for your patience. And if you have any further questions, please contact me or the corresponding author of this paper. Thank you.